And now comes the part where you say, okay, I do not want an automation. I want to do it myself. I want to achieve the best tuning I can get for my input data. I define my tokenizer from scratch and I train it only on my data set that I'm interested in, let's say all physics publication in I don't know, in theoretical physics or high energy physics. I don't care about anything else. No text about politics, nothing about philosophy, nothing about Twitter, Facebook. Just give me the documentation in my specific academic field. This is for you. Build your very specific tokenizer from scratch, optimized for your dataset. And you remember, we are still in the input dataset representation that we choose. BpeTrainer tokenizer for you, just as an example. Maybe if you're interested, I can show you a different BERT-based tokenizer or word-piece tokenizer. And our recipe again. Now we do the perfect fine-tuning for our car. Start with all the characters present in the training corpus as tokens. All characters. If you're in Chinese, quite a lot of. If you're in English, you are lucky. Identify the most common pairs of tokens, which characters go together, and merge it into one token. This is typically BPE, and repeat it until the vocabulary, that means the number of tokens, has reached the size I tell the system to have. Let's say in theoretical physics, I know if I download 30,000, 50,000 project description in theoretical physics today, I know I have about a unique vocabulary of the size of 42K, 45K, if I include a little bit of mathematical theory. So I tell the system, hey, I need a huge vocabulary size of 42,000 tokens. Of course, we can make it now easy for demonstration. We choose a predefined dataset that is provided by us, of course. And we just downloaded it. We unzip it. We have a look at it. Come on, come on, come on. Heaven's sake, I just download from Amazon AWS. Takes so long. Okay, I'm back in a second. And here we are now. We have extracted our file, we have unzipped our file. You can see that now I have it in my directory somewhere over the rainbow. Oh, where is it? Here, Wikitext. Here is our new directory. Jesus. And now I have from tokenizers. Now I import my tokenizer, I import from the models my BPE model. I say, hey, this is it. This is the model I'm looking for. And then I have from the trainer model, I have my BpeTrainer model. And if you look at this, you have here the class definition. You can decide your vocabulary size, like 30K. Your minimum frequency, like 0 is default. Show the progress, and here we go, the alphabet and whatever. And now I say, okay, just make it fast. My vocabulary size is 5,000 tokens. My minimum frequency is 2, at least 2 times the same frequency the same configuration should there be. My special tokens are classical tokens I define. So this is my BpeTrainer. And we could run now our tokenization right now, but this would not be optimal if I follow here the nice people from HuggingFace and they say, hey, without a pre-tokenizer that will split your input into words, you might get tokens that overlap several words. So you have a pre-tokenizer that splits you on white spaces. So finally what it does, it says, hey, we look at words and then we do the split. And of course we have some test data, some training data, some valid data. This is all great. And now we come to the huge job of training a tokenizer. And let me be clear, this is not training our deep learning model. This is just, we're still at the input data pipeline side. We are training a tokenizer to get the optimal vocabulary and the optimal tokenizer representation for our specific data. We are fine-tuning to the max. And here we start. This is it, tokenizer.train from our files, and to trainer, the BPE trainer I defined. This is it. Now, depending on your system, I have 6-year-old laptop, so it's going to take some time, but I just have 5,000 tokens, so this should be done in 10 to 20 seconds, I hope. 22. Yes, it's done. And of course, if you have your tokenizer, you can save it, you can reload it. But what we are interested in is, of course, to use it. And then what we do, we have this new tokenizer, this new optimal tokenizer, and now we apply it that we encode our sentence. Done. Now, of course, we're interested in which tokens he could identify, which words are in our vocabulary, and that we see, oh, wow, this is not so amazing because, again, quantum, it doesn't know quantum mechanics. Oh, no, what happened here? Probability, oh my goodness, yeah? So the training text, as we can deduct now, in our input data, and our input data was Wikitext 103, does not include anything about quantum mechanics. Well, what a pity. And we end up with some words that the system knows from the training, like quant, mechanics, and probability, splitting everything. Squared, my goodness, what happens here? It knows at least density, but even probability it doesn't know. So this is definitely something where we know this vocabulary, this training text is not fitted for our task. The vocabulary is horrible. And if you just look at the IDS, you would say, well, that's some nice numbers. But you have to translate it back into tokens and see that your training data set was not optimal for the training of your specific corpus of your sentences that you want to have the system, that the system learns those sentences. So the representation, the numerical representation of these sentences is not optimal. And even if you do now the post-processing, that you say, okay, let's put in those little special tokenization marks like CLL and SEP and whatever on my sentence. Yes, I have now my CLS and my separator here. But I mean, you can see how this, even I cannot read these sentences anymore. And of course, if you have more than 2 sentences, you have multiple sentences in a batch, and then you just have tokenizer encode batch. So the batch size you define whatever. And then if you use your special new tokenizer, you can have it as a BERT tokenizer fast, where you define this as the tokenizer, or you can save it locally with a pre-trained methodology. Okay, what else? HuggingFace dataset library. Should I show you this? No. This is much too much. You can train from an iterator with a train and a length dataset, and this is it. Okay, GPT-2. You have GPT-2 as an auto tokenizer. You can load it, you can play around with it. I don't need to show you this. And I think this will conclude our video for today. Maybe if you're interested, I show you how to optimize, how to build your own word piece tokenizer, like for the BERT system, for your specific training dataset, for your text corpus that you've chosen. Maybe it's just chemical literature, or maybe physical literature, or literature about, I don't know, philosophy. You want to have a special training data set. You want to have a special vocabulary set. You want to have a special representation of your input data to your BERT model that you then can optimize in a much faster way. This would be maybe the content of a next video, the word piece tokenizer, a handmade word piece tokenizer like BERT. But let's say today I showed you how to build a tokenizer from scratch, a BPE tokenizer, and this was it. I hope you enjoyed it. I hope you learned how important tokenizer are for your NLP system that you want to train, and that your input data pipeline, a numerical presentation that is fed into your deep learning system, the optimization here is important for the overall performance of your AI system. Thank you, and I see you in the next video.